Okay, great. Thanks, Philip. Appreciate the introduction, and welcome everybody to the webinar today. As you know, we're going to be talking about shelf life and stability studies. So by way of a quick agenda, I'm just going to start off with a couple of words about, what more specifically what we're going to talk about later in the webinar, and a few other just main topics that we're going to cover, because a key question in shelf life is determining when does the product cease to be fit for use. We're going to define how we come up with these kinds of definitions or specifications of fitness for use. The bulk of the talk, though, is going to be talking about some various methods that you can employ to actually estimate the shelf life of a product. There's actually different techniques that are used and can be used, and it really is going to just depend on the couple key points about your product and how long you have available to test. One method we're going to talk briefly about is the standard life data analysis or reliability analysis, where we're testing to failure, and then we're more or less using that failure time data to come up with estimates of shelf life. But really the point of the talk was more to talk about stability studies, where we're monitoring product characteristics over time, and we're using that data to extrapolate through a model and again come up with an estimated shelf life for the product for one or more characteristics. So we'll go ahead and get started. All right, so by way of introduction, I just want to kind of define a couple of things. So I'm referring to a stability study, and the way I think of a stability study is it's basically a kind of an experiment that we're going to conduct where the goal is to understand how the product degrades over time, usually prior to it going into use. The mathematical methods can be more general. It doesn't have to be strictly shelf life. It could be we're monitoring a product as it's under use and monitoring some degradation of the product as well. So the statistical methods don't really care whether we're talking about truly shelf life, monitoring just time that a product can sit on the shelf not being used versus a product that is being used. So some of these methods are more general. So again, in a stability study, often the goal is to estimate the shelf life. Again, it could be we're not necessarily the shelf life's not so important, but we're trying to just understand how the product may or may not degrade over time. So that's kind of an introduction as to what I'm referring to with a stability study. Now, since the focus is on determining shelf life, we have to think about what would cause a product to no longer be fit for use. So what is the time period that we'll call a shelf life, where up until that time the product would meet its requirements. So one thing is that there may be multiple failure modes. So I do a lot of work in the reliability area, and to think that there's only one way a component or a system could fail is a little bit simplistic. So if we have the condition where most of our products must meet multiple requirements, then we want to think about, is the purpose of the study to really focus on one failure mode or potentially all failure modes? So that's going to be one issue. So examples of failure modes could be just the appearance of the product, its texture, taste, if we're talking about foods and beverages, microbial counts. Just any engineered product may lose effectiveness, and there may be corrosion or reduction in strength, either in use or on the shelf. So it could be any performance measurable that we're referring to. As far as how you set up the study and the analysis options, one option is to select a primary failure mode that you're aware of that will be likely to be the one that fails first. I notice when I'm in full screen mode, I'm losing my slides. I'm going to go back to this screen. Philip, if this is not visible or good for the participants, let me know. Another option than just focusing on one failure mode would be to actually set up the study so that you can account for multiple failure modes. So for any of you that have done any kind of reliability analysis where you test products to failure and then record the failure mode, there are all kinds of ways to set up censoring, and we'll talk about censoring in a minute, to incorporate both failure modes or any number of failure modes into an overall reliability, or in this case, shelf life prediction. All right, so our focus is going to be on more quantitative studies. So that implies that we have some kind of objective specification limit or criteria for determining whether a product is acceptable or not. So if that product is objective and we can measure it, then of course we need to make sure that we have an adequate measurement system. And so that would be a prerequisite, ensuring that we're able to measure repeatedly, and if we have different people involved in measuring, that we can measure, two operators can reproduce themselves in what they're measuring. And, you know, referring to just normal measurement systems assessments like gauge R&R and linearity studies, I'll just call that a prerequisite for doing any kind of this analysis with data. Fitness for use may be determined subjectively by taste or appearance. Again, the results are going to be subject to perhaps more measurement error and subject to differences of opinion. But again, we want to make sure we validate the measurement system, specifically the people who are going to be assessing things for the purposes of this shelf life study. Now, when we talk about shelf life, also fitness for use, I see this mistake sometimes in the reliability world where people want to just say the product has should have a life of 1 year or a shelf life of 6 months. And it's not really clear what percentage they're referring to. So when we want to try to quantify shelf life, we need to set aside some percent that could fail to meet its fitness for use requirement at the shelf life. So for example, we might say we're going to define our shelf life to be the time at which 1% or maybe 5% of our product is expected to no longer be effective. Okay, saying 0% is not really going to work because we're going to be dealing with distributions and models that to get to 0 is not really going to be possible. So we can make it arbitrary close to 0. But we need to specify some proportion, just like we would a reliability metric. We want to say the reliability target, say, at 3 years in service is 99.9%. Okay, we're not going to call it 100% because we have to allow for some chance that that's not true, at least statistically speaking. And we'll also assign a confidence level to this. Let me just say, caution you, some people will think about coming up with a shelf life or criteria based on observing a statistical difference from a baseline value. So from like right after production, they'll take some measurements and then monitor until there's a statistical difference from what they initially produced. Now there are a lot of times where we do look for statistical differences. Say we move a production line to a different facility, or we want to compare, has there been any significant change in the process? But I would just caution you against using that idea in a shelf life study, mainly because you know, what's really important is at what point does the product practically change in terms of its use for the customer? When did the performance of that product actually change in a significant way from a practical perspective? So as you probably know, statistical differences and practical differences are not necessarily the same thing. We usually do try to select sample sizes such that when we conclude a statistical difference is occurring, that actually means something from a practical perspective. But given that you may be using a large sample size and be detecting a statistical difference, that in itself should not be the driver for determining shelf life, because the statistical difference that you can detect may not be of any practical significance to anybody. All right, so we're going to talk next about several methods for estimating shelf life. And let me just